Okay, good afternoon everyone. Today we will to present chapter 6 which is about district cooling system. My name is Ahmad Azlan and my friend is...
My name is Marhaita Sharika Yunus.
And for the next slide I will to give my friend to present it.
Okay, I want to continue slide about what is district cooling system. First, district cooling system is centralized cooling system for multiple buildings. Like one system supply cooling to several buildings within the same area. And number two is chilled water is processed at a central plant. Like water is cooling using chiller at a single location before being distributed. Number three is distribute thoughts underground piping. For example, chilling water is distributed to buildings through a network of insulated pipe. And number four is eliminate the need for individual chiller. Like buildings do not need their own cooling system, saving space and installing costs. And last one is more energy efficient and cost saving. Like use energy more efficiently and reduce operating and maintenance costs. Okay, next about the district heating cooling system. This is for example diagram heating cooling system. In some countries that have substantial heating demands, the plants can to form a district heating and cooling system. Next, about the main component of district cooling system. Number one is chiller. Procedures chilling water for cooling. Number two is cooling water. Remove heat to atmosphere. Number three is pump. Circulates water throughout the system. Number four is piping system. Distributes water to buildings. About a typical district cooling system comprise the following components. Number one is central chiller plants. Generate chiller water for cooling purpose. And number two is distribution network. Distribute chiller water to buildings. Number three is consumer substation. Interface with buildings, our air conditioning circuit. Next, about central chiller plants. This is the example chiller plants. Central chiller plants. Chiller water is generated at the central chiller plants by compressor driven chillers, absorption chiller, or other subs like ambient or free coolings. Number two is large and energy efficient water cooling chiller installs to take advantage of economy for scale and cooling demands diversity. Number three is seawater condenser or cooling tower uses to reject waste heat from the central chiller. Okay, next the types of district coolings. For the electric chiller system, use electricity as the main energy source to operate the cooling system. Number two is operate based on vapor compression cycle to produce chiller water. Number three is produce chiller water that is distributed for buildings cooling application. And number four is widely used in commercial and industrial buildings due to its reliability. For the advantage and disadvantage electricity cooling system is first, I want to talk about advantage electricity chiller system. High energy efficiency, easy to control, reliable reliable cooling performance. For the disadvantage, high electricity consumption, high installation costs, and requires regular maintenance. For the absorption cooling system, use heat energy such as steam, hot water, or gas instead of electricity. Number 2 is operate using absorption refrigerant cycle, not vapor compressor. Number 3 is procedures chiller water for buildings, cooling application, and number 4 is sub-tables for areas with worse heat or limited electricity supply. This is advantage and the advantage for absorption cooling system. For the advantage, low electric consumption for tables for industrial use, and number 3 is utilizes worse heat energy. For the disadvantage, low efficiency compared to electric chiller, and number 2 is high initial cost and large system size.
Okay, next for the comparison of absorption chiller and electric chiller. COP for absorption chiller is 0.54 to 1.1, electric chiller 1.0 to 8.0. Floor area. Absorption chiller occupies 50% more space and electric chiller smaller space required. Weight for the absorption chiller is at least twice as heavy, electric chiller lighter. Installation for absorption chiller is shipped in section, needs fill and welding. For electric chiller is factory assembled. And then for refrigerant, absorption chiller installed on site with absorbent. For electric chiller is pre-installed from factory. Noise and vibration. For the absorption chiller is quiet, low vibration. For electric chiller is more noise and vibration. Okay, distribution network. For the system district, cold air is discharged from cooling source to the consumer station through a supply pipe and return after heat is removed. The pump distributes cool air by creating a pressure difference between the duct and the return, allowing smooth airflow. After heat is removed, the air returns through the system and the process is continuing. Okay, for the next application, the application is used district cooling system is number 1, shopping mall. Shopping mall is require high and continuous cooling. Number 2, campus. This is for the campus. This system can multiple building connect in one system. Number 3, hospital. Hospital need this system because hospital need a stable and reliable temperature control. Airport. Airport is a large area with high occupancy and the airport need the district cooling system. And next, for consumer substation or user station. Interface between district cooling system and building cooling system consists of AHU, heat exchanger, and chill water piping. Connect district cooling system chill water to the building. Heat exchanger transfer heat between district cooling system and building system. Can be direct or indirect connection. Okay. Benefit district cooling system is number 1, energy or cost saving. It is because the district cooling system uses less energy due to the centralized system, reducing electricity and operating costs. And number 2, reduce the greenhouse gas emission. This system is low energy use and help reduce carbon emission and environmental impact. Number 3, reduce noise pollution. This system is centralized equipment, reduce noise and vibration in building. Okay, and next, benefit number 4, reduce refrigerant usage. It is because the system uses less refrigerant overall, reducing risk, leakage, and pollution. And number 5, improve building space and utilization. No need for chiller room, so more space can be used for other purpose. Improve city skyline. No rooftop chillers, allowing better building design and aesthetic. It is because the piping of the system is go through the underground. And then next, advantage and disadvantage between of conventional and district cooling system. For the conventional system, advantage number 1, lower installation cost. System operates independently. And disadvantage, high electricity consumption, requires more manpower, higher maintenance costs, and requires larger space. For district cooling system, advantage, higher energy efficiency, environmentally friendly, save building space, improve urban appearance, reduces manpower for operation and maintenance. And disadvantage is higher initial installation costs, possible legal or coordination issues between multiple stakeholders. Okay. For the conclusion, district cooling system is an efficient centralized cooling system that supplies chilled water to multiple buildings, helping to reduce energy consumption, operating costs, and environment impact. Although it requires a high initial installation cost and proper system coordination, it provides reliable performance, safe building space, and highly suitable for large-scale building such as campus, hospital, and commercial building. And that's all from us. Thank you everyone.